2.7, inverse functions preparation. Decide whether a function is one-to-one, and if it is, find its inverse. Suppose we define the function. Okay, so these are functions because every time we plug in a different x, we get a different y than the x. So if I plug in -2, I always get a 2. If I plug in a -1, I always get a 1. Plug in a 0, I always get a 0. 1 will give me a 3, and 2 will give me a 5. So this is a function. But they're asking for a specific type of function that is a one-to-one. Find its inverse. So we can form another set of ordered pairs from G by interchanging the x and y values of each pair in G. We can call this set F. So the set F is, we got 2 to negative 2, 1 to -1, 0 to 0, 3 to 1, and 5 to 2. So basically the function works both ways is kind of another way of thinking about it. So for every x value there is one and only one y value. For every y value there is one and only one x value. So it goes both ways. So to show that these two sets are related as just described, f is called an inverse of g. For the function f to have an inverse function, f must be a one-to-one. Okay, so one-to-one function. In a one-to-one function, each x value corresponds to just one y value, and each y value corresponds to just one x value. Okay, so these are examples of functions, but not a one-to-one function. And the reason the first one that I have on the left is not a one-to-one function is because both 2 and 3 go to 7. So since 7 gets it both, 7 is, both 2 and 3 give you a 7, this is not a one-to-one function. Whereas if you look the other way, every x value corresponds to one y value, and every y value corresponds to one x value. So that's what makes the second one a one-to-one function. The symbol you use for inverse function is f to the -1 looking power, but that's not really. It's the inverse of f, or f inverse is the way you would read that. So an inverse of a function. The inverse of a one-to-one function, f, written f in the -1 power, right, is the set of all ordered pairs in the form of yx, where xy belongs to f. Okay, this is getting a little terminologically dense. So I'll show you an example of this algebraically. Decide whether each function is one-to-one, and if it is, find the inverse. Okay, so for every -2 we get a 1, for every -1 we get a 0, for every 0 we get a 1, for every 1 we get a 2, for every 2 we get a 2. This is supposed to be a comma, not a point. Okay, so far it looks good. What about the other way around? When we plug in a 1, and I can just rewrite this, but so rewrite, why not? We'll do this -1. There we go. So let's just flip everything. 1, -2. So far that's good. What about the other one? 0, -1. So far that's good. What about 1, 0? So far that is good. What about a 2, 1? So far that's good. And what about a 2, 2? Okay, let's see about this. So sometimes when I plug in a 2, I get a 1, and sometimes when I plug in a 2, I get a 2. So this is not one-to-one. This is not a one-to-one function. I'll just put not one-to-one. That's for me to write. Okay, cool. So let's try the other one. And you can do it visually. Again, we'll just confirm this is a function. 3 to 1, check. 0 to 2, 2 to 3, 0 to 4. So 0 gives you 2, and 0 gives you 4 sometimes. So this is not a function as well. Pretty sure there's a typo in the first one that was meant to be a one-to-one function, but I miswrote it. But anyways, it's okay to go through and disconfirm that it's a function. So this isn't even a function, because sometimes when I plug in a 0, I get a 2, and sometimes when I plug in a 0, I get a 4. The other one was a function, but it wasn't a one-to-one function, because sometimes when you go the opposite direction, you have both 1 giving you a 2 and a 2 giving you a 2, essentially. So if you were to graph it, you would see that. So ditto, right? Same thing over here, not a one-to-one function. So horizontal line test. A function is one-to-one if every horizontal line intersects the graph of the function at most once. Okay? So as you can see, this example right here, a horizontal line hit this twice. And again, this is what I was talking about, where -2 will give you a 4, but 2 will also give you a 4. So this is not a one-to-one function. Okay? It is a function, and you could use the vertical line test to test this, right? So every vertical line only hits this once. Okay? But it's not a one-to-one function, because whenever we do the horizontal line test, it hit it twice. Hit it twice, right? So let's try a couple more. So horizontal line test again. It does not look like this one appears to be, this is not a one-to-one function, because again, in this case it hit 3 times, right? They're 1, 2, 3, so it's not one-to-one, not 1, 2, 1. Okay, how about this one? It passed the vertical line test, boom, and it also passed the horizontal line test, so you could say this one is 1, 2, 1. Example, use the horizontal line test to determine whether each graph is the graph of a one-to-one function. Okay, so vertically, it passed the vertical line test. All vertical lines only ever hit in one place. Excellent. And if we flip it and we do the horizontal line test, it only ever hits in one place, so it passes the horizontal line test. So since it passed both those tests, we would say this is a 1, 2, 1. Okay, now how about this one? Does it pass the vertical line test? Check. So it is a function. Does it pass the vertical line test? No, it hits it twice. So we would say this one, it's a function, but it's not 1, 2, 1. So it's not a one-to-one function. So more tests. Use the horizontal line test to determine whether each graph is the graph of a one-to-one function. I'm still going to do both the function ones, but these are all functions, so it's kind of a waste of time. These are all functions. They all pass the vertical line test. This one passed the horizontal, so it's 1-to-1. This one failed. Hit it in 2 places, so it is not a one-to-one. This hit it. This can hit it more than once, right? So for instance, here to here, it can hit it 3 places. So again, not one-to-one, and this one right here, no matter where I do a horizontal line test, it only hits at 1. So this one is one-to-one. So this one is 1, 2, 1. This one is not. This one, I'm going to put yes. I'm sorry, no. Put that correct one there. This one is not. And we'll put this one is. This is one-to-one. I'm being lazy. Okay, let's try some more. Use the horizontal line test to determine. Okay, well, this one hits twice, so it's not. This one hits once. This one's 1, 2, 1. This one hits once. So again, we're dealing with 1, 2, 1. Find an equation for, so basically inverse function for this one. Okay, so what we do is we replace the f of x with a y, and we rewrite the rest of it. Then we replace the x's with y's and the y's with x's. So we just flip the x's and y's, and then we rewrite it. Then we want to solve for the y, so I have to get this 6y by itself by undoing the addition of 5, by subtracting 5, and whatever I do to one side I do to the other. It gives me x minus 5 is equal to 6y. I undo the multiplication of y by 6 by dividing by 6, and whatever I do to one side I do to the other. Those 6's cancel out, leaving me y is equal to x minus 5 over 6. Over here, replace the f of x with a y. Rewrite x cubed minus 4. Then I switch the x's and the y, so y becomes x, and x cubed becomes y cubed. Next, I want to solve for the y cubed. I want to get that right by itself, so I have to undo the subtraction of 4 by adding 4, and whatever I do to one side, I do to the other. That gives me x plus 4 equals y cubed. So I want to undo the cubing of y by taking the cube root. Whatever I do to one side, I do to the other. That gives me y is equal to the cube root of x plus 4. Next, I have f of x is equal to x plus 12 over x minus 4. Replace the f of x with y. Then I say x plus 12 over x minus 4. Next, I replace the y with x and all the x's with y, so it becomes y plus 12 over y minus 4. Next, I don't want this y minus 4 to be down here, so I'm going to multiply both sides by y, not x, by y minus 4. Whatever I do to one side, I do to the other. Y minus 4.
These cancel out. I'm going to rewrite this as x times y minus 4 because I'm going to distribute, and that will make it look a little neater. So x times y is xy, and x times negative 4 is negative 4x equals y plus 12. There we go. Now, I want to solve for y, so I want to get all my y's on one side and all the x's and constants on the other. So I want to get rid of this positive subtraction of 4x by adding 4x, and whatever I do to one side, I do to the other. But I also want to get the y's on the left side, so I want to get rid of this positive y over here by subtracting y, and whatever I do to one side, I'm going to do to the other. So negative 4x, positive 4x cancel out. The positive y and negative y cancel out. That leaves me xy minus y equals 4x plus 12. Okay, now this is a little bit different. You haven't seen this before. I'm going to factor the y out to get it by itself. And xy divided by y is going to give me just x, and negative y divided by y is going to give me a negative 1. So when I factor it out, that's the same as dividing, right? So I divide this and this by y, and I put the results within the parenthesis. Now that I have kind of y is being multiplied by these parentheses, I want to get the y by itself. So I undo the multiplication by dividing, and whatever I do to one side, I do to the other. Those cancel out. Leaves me y is equal to f of x plus 12 over x minus 1.